How is everybody? We have a great group this morning. Did you have a good long weekend? Get a lot done?
Sure did.
No?
Oh. Get up at 6.
Been sick?
Saturday and Sunday.
Oh no.
And I didn't end up working full shift either day.
That's awful. You feel better though?
I'm just really tired of anything right now.
You don't know?
I wanted to go back and nap after each shift. I just
Yeah. Well, I hope you feel better. It's week 11. We're getting there. So you guys have learned so much, doing so much C# stuff. And if you look back at some of our early stuff, you'd be like, that was so easy. Today I wanted to start out with our class that we were working with last time and look at how we could make a collection or an array full of our class objects. And then we'll use our class to generate some test data, like for itself or for its own application. And so I think that the best place for us to start is with a brand new project in Visual Studio. Let's try it. I have one open, so I'm going to close it. And then I would like to, too early. I'd like to, like I said, create a new project. And this is going to be a console app. And I'm going to call it L11 so that we're looking at a different project, but we'll go ahead and we can call it our audio store app or audio store inventory app or whatever we called it last time. I tend to change that between classes, so anything you like. And we'll get this lesson 11 one going. Now, when I create this project, I'm not going to have any of my information there from my last project. So I would like to bring that class file in, and I know I have it out there in my project folder, so I'm going to see if I can find it. Now, with a lot of tools, like if you were creating a website or something that didn't have any sort of linkage information saved in the project, you could just drag and drop files in here. But with Visual Studio, it kind of likes to control things. So to make things work their best, not that we couldn't do it another way, but just to make everything work properly, we're going to select our project and we're going to choose, we're using Solution Explorer, of course, and we're going to choose Add. And we want to add an existing item because that class file already exists out in our file system, so it's an existing thing. It doesn't exist in this project, but we're going to make it. So I'm going to add existing item. Now that puts me in the project folder for this new project. And I want to move to the project folder for that project we were doing last week. So if I look up here at my breadcrumb path, the easiest way for me is to go all the way back to my Visual Studio projects folder. And then I can find my L10 audio store app. and double click to go into that project folder. Now inside that first folder is like our whole solution. So inside of there, we have a folder for each project. This solution only has one. So I'm going to open it and get my CS file. We called it compilation, kind of a long name, but that's the class file that I want to grab. So let me add that to this project. And then in the meantime, I'll get it posted out to our team space. Now, those of you who have some late arrivers around you, help them get this accomplished, or else we're not going to get anywhere, or they're not going to get anywhere, that's for sure. So I'm going to post this CS file code into our Teams chat. Let me expand it all. It takes me a minute to think of where I am. I have to edit outlining, and then remember if I toggle out outlining, it'll expand all that. I'm going to just select all in this class file and copy it and paste it into our chat. No, I think I'll just get the CS file. Let me upload it. Okay, so in the chat, you should see this CS file that we just brought into our new project. So brand new project, either create a new class called compilation and copy and paste all of the code from this file into it, or choose add existing item and go locate this file in your file system and bring it into your project. Get everybody there so that we're not in a bad situation. So looking at our project, we should see that our program.cs file just has our little hello world code left in it, but our new compilation.cs file should have all of our code for our audio compilation. So let's look through our class. Remember, this was last week, and I know it was a really nice long weekend. We started out with all of our data elements, our private class data. And then we created these public properties that we were just getting started with, where we could allow access to our private class data through these public kind of method names. So we saw that it's a convention to name all of our private class data with lowercase letters at the beginning of their variable names, and all of our properties to start with uppercase letters. Then we can see that association ourselves. We're not making that association in C# until we put this code in, saying, oh, if somebody asks for this property with the uppercase ID, we're looking at this class variable with the lowercase ID. That isn't defined to Visual Studio anywhere except for in our code. So it's not something that is hidden. The thing that's hidden to us is when we set a class value, this value is something that gets passed to us automatically, and we don't have to worry about it. So when we're working with our properties, it's a little different. I'm going to scroll past those. We see our constructors. Remember, we have our first default no argument constructor, bless you, where we're setting up all the default values for an instance of our compilation. And then we created another constructor for in case somebody had all of the information to pass to us to create this compilation. We saw as we were creating this, we might need additional constructors depending on the needs of our application. We might have to create more of these overloaded constructors with different parameters being passed in, depending on our needs. Finally, we created this method toString, and we said it overrides the system toString method, which means that if somebody names our class instance, just names it, then it will run this toString method. We output all of the information about our compilation here in our toString method. So we're saying that we can represent our compilation as a string by running the toString method. That's an instance method. It looks at the data for the particular instance of compilation we're looking at. We had one static method, however, and in our static method, we calculated a value. We just took the number of tracks times the cost of the compilation and returned that value. We made this a static method. We said there's only one of them. So every single instance of a compilation that we have would all use this same calc value method. Kind of hard for us to see that stuff, just something that we have to know. That's why we put a nice region comment here, that this method is static. It has the static keyword. It's a little different than all of our other methods. Okay, so we've got our beautiful class here. Everything that we need is in it. So let's get away from it now and just use it. Let's go to our program.cs file, and let's rename that. We've tried lots of different names. For this example, let's name it driver.cs because it's driving our program. It's controlling it. And I'm going to say, yes, I want to rename everything. Hopefully one of these names will key something in somebody's head and they'll go, ah, you see what's going on? Lots of people are seeing. Get that light bulb moment. So we know that we can create a compilation now because we say that whenever we create a class in C#, we've created our own class type. And our type is whatever the name of our class is. And in this one, it's compilation, right? So if I put that word in, the Intellisense Editor recognizes it right away. It's something meaningful, turns it that nice blue color saying, ah, I know what that is. It's something that has to do with your application. Let's say we're going to create an instance of a compilation called CO. We always have to have the new keyword if we're going to create an instance. It's a new one, and it's going to be a new compilation. Now, we're right here sitting in our parameter area. What are we going to pass in? Which constructor do we want to use? If we leave it like this, we use our default no-var constructor, and it'll load all of our values with default. But the Intellisense Editor is up here telling us you have options. You could specify all of these different values. So let's do that. Let's create one where we specify everything. First, we have an ID. Let's make our first compilation ID 001. Now, just like when we created our class file and listed all of these parameters, I told you we could put one on each line and it would be kind of easier to work with in the future. We could do that same thing when we're loading these in as arguments to satisfy those parameters. So let's say our album here is going to be the White Album. I'll stick with it because we know it's an album. Now, notice how the Intellisense Editor is jumping parameters here, showing us what the next thing we need is. The next thing I need is art or artist. So I'll put the Beatles. Now, my next data field that I need is the number of tracks, and it's an integer. We decided that this album had a lot of tracks. We'll put 30. Next, we want the cost of this thing. We saw that could go crazy. we'll say that it cost us $10. So this is not how much we're going to sell it for, but how much we paid for it. And then lastly, we need our Boolean value to say, is this a collectible album? And we'll say, yep, this one is. Oops, it didn't turn a color. Oh, I must need it to be lowercase. So now I'm passing in all of this data that I need to create an instance of our class. Excuse me, let's put a comment up here to that effect. Create an instance of our compilation class for White Album. Now, one thing that can get students confused, sometimes they want their class to be intermixed with their data, and it can get kind of confusing in our head. So remember, the class, this compilation, is the template. What information are we keeping about every album or every cassette tape or every item we ever get in the store? It's the template. Whenever we create an instance, we're actually putting in data for one of those items. But remember, our data is separate from this template that says what kind of things we need to keep track of. So every once in a while, I'll see a student who creates a class and they'll say, oh, it's a compilation, but then they'll make their data elements be like the White Album or things like that inside their class. We don't want data confused with our class. Our class is the template of what data we need. So think about it. If we were going to make a class that was going to be a trip to an amusement park, we wouldn't want the class to be named Worlds of Fun. What if we want to go to Silver Dollar City? That class doesn't apply. We would want that data to be named name of amusement park, and then the data we would supply would be Worlds of Fun or Silver Dollar City or wherever our trip was going to take us. So keep them separate. The template defines what we're going to keep track of, and the data is that actual information. So now what would I need to do if I wanted to create another compilation? I could copy this whole thing, but let's print this one first. In our write line statement, we can just change this from hello world to print out CO, our compilation instance. So just like we give a variable a name, our instance has its name, and that's what we refer to when we want to do something with it, like print it out. So as we run through this, our write line statement is going to say, oh, we have this instance named CA. CO, what is it? Oh, it's an instance of a compilation. Does the compilation class have a toString method? Oh, it does. So let's run that, and that's what we'll print out. So we should see the output from our toString. You see it? I see some. Yep, there it is. Album ID 1 and all my information about the album. Did everybody's work okay? Let's get them fixed if there's any problem. What you got? Can you show us? Here, let me disconnect so we can see you. All right, take over. Can you zoom in just a little bit? Control scroll should zoom in. There we go. So let's see. Oh, let's look at line 59. What do you have at the end of that thing? Good job. So little teeny tiny problem. Save it and let's see if that runs. Little teeny tiny problem causing all sorts of issues. Is it running? Yay! What you got?
Mine's doing a typer namespace compilation could not be found.
Let's see it. See what we can do here. So what would that be? Just a quiz for everybody. What should we look at there? Just a harder one. Show everybody your compilation class. Is it really there? It looks like it's really there. So why can't it see it? Do it?
Didn't the using statement at the top of the driver series?
We could, but what else could we do? Are they in the same namespace? Don't they have to be in the same namespace to see each other? Let's check your namespace name. So anybody else who copied that class over could have that same problem.
On ours, it has this, like, we have a using statement, like using.
Using is another way to handle it, but you don't need to do that when you're in the same project.
So I need to have audio store app as the.
No, look up at the top. Where's your namespace name? Find your namespace name. That needs to be the same.
Oh, okay.
So it's probably other people that have that same issue. And if you couldn't hear Josh up here, he was saying, if you use a using statement, that will do the same thing, and it will allow you to use those other components that don't have that same namespace name. So either of those methods will take care of that problem. Good job. Thanks, Logan. We needed that one. Did that fix it?
Yes, it did.
Good, good, good. Anybody else? Because I'm sure that you run into something like that.
Just really quick, going over what the override, making the string overridden, or the toString. Just going over what that. Like,
okay, let's look at it again. Let's see. Let me find it. It's definitely hidden. And if we look at the system class, the default system class that owns everything in C#, it has a method called toString. And when we run that, so let's take out this word override. Now, when you take that word override out, we just get a green warning. It's like, are you really sure that's what you wanted to do? Because right now, you've got to have the new keyword or something. It's making it mad. So let me put that back in. And instead of just taking out that keyword, let's comment out this whole toString method. Dangerous, everybody stick with me here. So remember to comment something out. We could just go up to the toolbar and click comment out. There's some magic keystrokes for that too. Either way. So now I have no toString method in my class, which is fine. Now I'm going to go back to my driver class that's controlling things and run it again. Now it runs the default system toString method, which just shows me the name of the current class and what solution it's in. All right, so that's what I see. That I'm in L10 audio store app. That's my solution, and compilation is my class name. So that's all it shows me that by default. But then when I override that system toString method by putting it in my class and saying I want to override that default, let me uncomment that. Now, when I name my class, instead of running the system toString method that only gives me the name of my class, it will run ours. And it's because that toString method exists on the default system object. So as we learn more about object-oriented programming, we'll see that we can, if we have a parent class, we can override things in it too.
Okay.
So it's just because it's a system level method, we can override it.
And this is true of just all like methods.
If they
In C
exist
sharp.
at a higher level in our object-oriented methodology and they allow us to override them, yes.
Okay.
So for example, one that we were looking at the very beginning of our object-oriented stuff, we were looking at that Unity application. When you're working with a game engine like that, a game engine that you guys know has several events, like startup or the refresh event when the screen is refreshed. Those are methods that if we were game programming, we would override to put our own code in. So it's that same kind of thing. If that method exists in a class that we are below in the class structure, then we can override it. And that's definitely something that's a little bit more advanced. So for our toString, we have to be like, well, I know it's at the system level. That's my understanding right now. I can override it and make information come out about my instance instead of just the name of the class. So that makes sense. It's a little bit off the wall. We can run the debugger, though, to see what's actually happening. So let's try it. I'm going to set a breakpoint here where I create this new compilation. And I'm going to hope I've got those settings set. I'm going to go to Tools, Options, and I want to find my debugging. And what is it, this one? Step over properties and operators. Now I can never remember if I want it to be checked or unchecked. So I think I want it to be unchecked. But I might be wrong. So I'll click OK. Now let's see if that's the way we want it. You guys will always remember. You'll be like, that crazy woman. All right. It started up and it stopped right here, ready to create my compilation instance. I'm going to step into, oh, and I did. I got that setting set right. So it's showing us in our actual class file what constructor it's using. So that's the code that's running based on our creation of a new instance of our compilation class. Now, as we start running our constructor, we should see all of our data fields being set for this instance of our compilation. Setting everything up for it. It's the white album. And then it's done with our constructor. So it comes back to our driver class. Now, I'm going to click Step Into, and it should be ready to print out our information. So again, as we step into, we should see that it goes to our toString method and starts running it. It'll put out all of that information. And when our toString method is done, it comes back and it's all done. So let's create another instance of our album, or an album. I'm going to end this here. And we can just copy both lines of code. I'm going to copy and paste. Now, we have to have a new instance name. So let's make it CO2. We'll make it album ID 2. I don't know. I'll just change the album name, Sergeant Peppers. I'll make a long one for you. We'll say that this only has like 12 tracks and it cost us like $8. The collector, we don't think so. Let's make that false. Now, if we want to print out the information about this new album, we have to print instance CO2 because we gave it a different name. Now, when you run it, we should see output from both of our compilations. So we've got our first album and our second album. It would be nice if we just put those in an array, wouldn't it? And then we could just go through them all and not have to worry about giving them each a different name. So let's do that. We're going to create a new class. So come over to your project under your solution, and let's right-click and add a class. And we're going to call this class database.cs. So we're going to make this class generate test data for us. We don't have a database yet. We're not old enough to use databases. We're just too young to still learning. But we need some test data because all of this stuff every single time, either we have to type it all in or we have to put all this stuff in our main method that's all gross and hard to see for test data. So what if we figured out a way for us to generate test data easily so that we didn't have to worry about where we were going to do it? That's what we're going to do in this new class. Let's put a comment up there to say that. Database class, generate test data for compilations. So the first thing I want to do is make an array or a list of compilations. I'll make an array. So it's going to be my class name, compilation. Whoops. Intellisense found something else. And then I'm going to have those square brackets to say this is going to be an array of those things. And we'll just call it comps. Now I made this array global to our class. So we could almost say it's a class data element, isn't it? Class data, just like we were talking about with our compilation class. Only this class is worried about making a list of those compilations. So I can do that. I can have this data element out here in my class just floating because it's a global array. But all of my other code I need to have within a method. So let's create a method here for our database class. Let's say that this method is public. We want other classes to be able to call it. And it's going to return an array of compilations. So just like creating an array of compilations, we say data type is compilation, and I'm going to make an array. And that's what I'm going to return. And let's call our method generate data. So I've got to create an array. I called that array comps, and we're going to say it's a new array of compilations. And let's say we could have up to 10 of them. So this line of code is really going to allocate our array with 10 entries. And this line of code, if you remember, just there it is. Going to have an array, and it's going to be global. And wherever they create it, we don't care because we're going to be able to use it anywhere. It's global in our class. Okay, so now I've got this new array. I want to create an instance. So the first thing that I'm going to do is create an instance at index location 0. And I'm going to say this is a new compilation. And just like before, I'm going to specify which constructor I'm going to use by specifying data. So I'll say, oh, album ID 1. is the white album. I'm going to type this data in again. Don't want us to copy and paste and get off or out of whack or anything. And I want to actually think about what we're putting here. Again, we're specifying all of the information to create this instance. See, I think we said it had like 32 tracks, was $10, and true is a collector. Okay, so what's different about this instance versus the instance we created in our driver class? Well, this one has a different instance name, doesn't it? In our driver class, we named it like CO. Here, it doesn't really have its own name. It only has the name of the entry it is within our array. So we could almost call it like anonymous, right? It's a compilation that exists in this array. Let's create another one. Now I want index value 1 to be a new compilation instance. And we'll make it that second album. Long name. Good for us to test. And we said this one only had like 10 tracks and cost us like, I don't know, $8 and is not a collector. Yes, sir. What's the matter? Let's do another one. We have 2 albums here, or 2 compilations. Do a third one that's something that you would like. Now we're going to have to up our index. This is going to be number 2 in our array, and we'll make its ID match. I don't know any albums. Let's we'll do just like 70s retro, because we have this used album store. They're not going to have too many new ones. Oh, Bob Seger, he probably has like, I don't know, 15 tracks, and we'll say this one was $4. Now, this is not a lot of test data, but I hope you get the idea. If we needed 15 elements of test data, 15 different compilations, we could just keep extending this class, adding more, until we had that many entries in our array. We're not doing anything fancy here. We're not doing anything mysterious. We're just manually adding entries to this array so that we have a whole bunch of collections to work with. So now when we get done, we've got all of the collections built in our array that we need. We can return our array. What's our array name? Comps. So now if we look at our class here, I'm going to control scroll in a little bit so we can see all of it a little better. First of all, we named our class database. So we're going to have to create an instance of that to get it to do this for us. So it's something that is We'll have to create an instance of it, and then it should generate just these different entries in this array and return it to us. So let's update our driver class to use that. In our driver class right now, we have almost the same code. I want to clean that out a little bit. I'm just going to leave one right line statement in here, and I'm going to delete everything else. Let's create an instance of our database class. Call it DB. And then we can say, DB, generate some data for us. Where do we want to put that data? We've got to save it somewhere. Well, it's going to give us back a collection of compilations. So I want a compilation collection. We can call it data. Get my code in here correctly. So we had to create an instance. Then we're going to call our generate data method, placing returned data in an array called data. Now that all of our data is in this nice collection, we can use our for each command to process each of the instances. Now, my for each statement is going to start with that keyword for each. And then if I press tab, remember Intellisense drops in that default code. My collection is named data. The variable that I get from each instance in our collection is going to be one compilation. So I guess I could call it COMP for compilation. And here where I have this keyword bar, that's where I have to specify the data type. And my data type is compilation. That's the name of our class. So now let's see if I can use that for each loop to just print out each of those compilations. My database class, put them all in there for me real nice. Now I just want to print each of them out like I was making a list for the owner or something of all of the different data we have. So let's run this. So I start out with my album ID 1, album ID 2, and album ID 3. Everything looks good there. Did everybody get all of their test data printed out? Let's put a breakpoint on our for each loop. Of course, we could put breakpoints all through this because it's doing some things that would be great to watch in any of our lines of code here. But I'm going to run this. And it stops here at my for each loop. And I'm going to go ahead and step into. It says, oh, I'm looking at your data. Now remember, our data is down here in our locals window. We could expand it, and we could see the instances of our compilation class down here. Because they are each instances of a compilation class, we can expand to see each of our data items. You just see so much. All right, I'm going to step into, for each of the items in our data, we're going to call it COMP, and we're going to print that out. So that's going to run our toString method. And then we'll go to our next one. And when we print it out, it'll run its toString method. So whenever you create a class item, you're basically just creating this package of all of the code that goes along with it. The code that defines what kind of data elements it has, the code that defines what sort of actions it can do, and many, many different things. If I keep going here, you'll notice that I'm going through our for each method a whole bunch when I don't have anything. So that could maybe cause us trouble. How could we get it to not do that? I'm going to think about that. If I had some sort of if statement or something I could use here to see if this compilation is maybe null. Let's see if that works. So I want it to only write it if it's not equal to null, not if it is. Now, I'm going to run this again. I still have my breakpoint set. Again, I noticed that I was printing things out that were empty, array entries. So let's see, I should get my first one, print, print, print. My second one, click, click, click. And my third one, now for this next one, I should be looking at an entry that's empty in the array. So sure enough, our if statement has fixed that problem. We're not processing those empty ones anymore. So that's handy. So as we look at this, we're all super happy about everything. I'm going to tell everybody at our office about how we could just create a class to generate test data for whatever class it is we're trying to test. And then the boss finds out about it, and he says, why are we having to create instances of this database class? It should be a static class. So why would that be? Well, we're working with this array. We only really want one instance of it in memory. We don't want to create, several different instances of it. It should be a static class. So let's see what we would have to do to change it. In our database class, if we say that our generate data method is static, then we've basically made it a static class, right? But oh, look, it's super mad. It gave me a bunch of errors when I changed that. Oh, it's kind of like missing a parenthesis or something. It goes crazy. But it's a little different because now it's complaining about every one of these, saying an object reference is required for this array. That's true because we have these compilation things. What if we make this array static? Can we do that? It didn't really say that we need to at all, did it? It complained about all sorts of other things. But if we make this array static, we can make that work also. The problem is we've said that this array is like global. It's kind of an instance variable. So for this to work properly, or at least the way it should to make sense, we're going to move this down inside of our static method. Let me clean it up there. I didn't get it. And I'll update our comments here. Well, that seemed like it made it even worse, didn't it? Okay, I'm going to undo. Control Z, clean all that back up. So to make a static class, we almost have to have this global variable that is our array. So when someone calls our generate data method, it's going to allocate the array, run through our code, and return all of those instances back to us. We have no errors in our database class now. We have a static array and a static method. So now let's go back to our driver and see if that changes the way we call it. Yes, sir? Yeah, that's what we all got. So that's what we're going to fix. So why is it saying that? We made it static, so we don't need an instance anymore. So instead of creating an instance, let me comment that out. When we're using a static class, we put the class name followed by the method name. And we don't have to have an instance created. So I'll put a little bit more to our comment. Create an instance of our database class, not needed for static class. So notice how sometimes just getting something to work isn't necessarily the same as knowing why it works or what it's doing behind the scenes. Getting it to work is the most important key part, but it's super great if you can understand what's going on behind the scenes too. Okay, so we see that we can create an array. I'm going to go to our database class. An array of instances of our class so that we can generate some test data. We see a little bit more, a little bit clearer about the difference between static and non-static. Still a little fuzzy, still a little static there, but it's getting clearer. So if I were to create a class of students, like student information, I could have a database class that just created several instances of students that I could work with and do whatever testing I needed to do. Because remember, creating our class is like creating a template. And so to test the template, we have to have some entries that use the template. And then that way, we can make sure that our template is working properly to allow other developers to benefit from it too, so that we can have some great sharing of code. Now, as you go through the Replit, it should be very similar. Again, look at videos, do as much practicing as you can so that it makes more and more sense.
So you're there, right?
what we were going to do this week, let me get something open here. We want to look at exception handling, and we've had some time here to look at a little bit more of our class information. With exception handling, we are talking about a runtime error. So let's create an exception in our application here. Go to your database class, and in your database class, set your number of compilations in your array from 10 to 2. As soon as you do that, when you run, you get an exception. It says the system returned an index out of range exception. The index was outside the bounds of the array. When we tried to create our third entry, it just overloaded everything and it caused an exception. So there are two basic kinds of errors from your Intro to Programming class. First of all, we have syntax exceptions, where we have a typo and our code won't compile. We can't run those kinds of things, right? If we have a syntax error, code won't run. But if we have a logic error like this, where we say we only need 2 entries, but we actually need more than that, that's something that causes a runtime error. That's where our user gets interrupted as our code is executing, and it's an indication of a logic error. And this is the kind of thing that we're trying to test for and prevent and keep from happening. So we can do some things with exception handling, and I'm going to show you some code here that you will be working on in the replit. We can do some things and implement some logic called a try catch. And I'm just showing you this code. This is code that you're going to be working on as the week goes on. But in this example, we have this try block, and if you notice it, it's just like a method in C#. It starts out with the keyword try, and then it has an opening and a matching closing curly brace. Within the try block, we have all sorts of code to try to do. If any of this code results in an error, then we have additional code down here in catch blocks to catch those errors. So in this particular code that we're looking at, we try to do all of these things. If any of these things result in a format exception, which would be us trying to use data invalidly, then this catch code will run instead of the system blowing up and giving that exception. So our user won't see that terrible error message, would you like to debug, what would you like to do? Because the catch code will catch it instead and say, oh, we can't handle that, we've got a problem. As we look down at this catch code, you can see we can catch different kinds of errors separately if we want to. That's what's happening in this code. If somebody tries to divide by 0, we would get a divide by 0 exception. So this code would run instead of the runtime error occurring. If we went through all of these and none of these exception types were the kinds that we experienced, then this catch exception that just catches all general exceptions would run. Now, a really cool thing with the try-catch block is we can also have a finally block. And when we have a finally block, it runs whether there was an error or not. So I could try to open a file in my try. If the file isn't found, I could catch that error. And in my finally, I could try to close the file either way, and I would make sure that it was taken care of. Let's get the replets going for this one, because this is, with the exception handling, there's not a lot of code. Yes, sir?
Is the
The format exception, would that be used for the index out of bounds?
No, let's try it and see what we get. So let's see what we would do here. Here, I'm going to put this in our generate data method. So up at the very top, I'm going to put the word try. And then I want my opening, whoops, it did some helping for me. Let me get rid of that. I want my try in the opening curly brace. I'm going to get rid of all of this extra stuff it gave me. Now, at the end of our method, whoops, right before the return, I'm going to close our try. Let's make sure we can see that so you can see where I am. Little small. So in our generate data method, the only thing we have is this try with a little error and then our return statement. Now, we want to try all that stuff. Now, if we encounter an error, let's catch it. And we saw from that code, we could just put the keyword exception, and that would catch any sort of error. And then they gave that exception a name. We'll call our exception EXC. Because think about that exception. It's like, it's got all this debugging information that's written to it. It has like dump files and all sorts of things going on out in the operating system. And we're going to name all that stuff EXC. Now, in this catch, we're going to print out some information about that exception, like the message, exc.message. Now we're going to try to say, finally, no matter what, let's go ahead and try to return this comps array to our caller. Oh, it's mad at me. It says that control cannot leave the body of a finally clause. So whenever we have these return statements like this when we're working with exception handling, it could be a little difficult to work with. Let's move it back up into our try statement. And our finally, we'll just put a console.writeLine that says, and the finally clause. So that looks good. We still have the error, but I've got like this weird error up here in my generate data. Notice how that return statement is still causing us trouble because of the try catch. So I'm going to have to put it here at the end outside of their try catch statement. And sometimes we have to do things like that just to satisfy the compiler. There is no way that this line of code will ever get to run, but the compiler is just super complainy about it if we don't put it there, so we will. Now I've got a bunch of yellow here, meaning it's been a long time since I've saved. So I'm going to save this and try running it now. So I know the last time I ran it, I got that exception. This time, I'm just seeing our first two albums because when we crashed, we got this message, index was outside the bounds of the array. Let's make that a little bit more meaningful. Here in our catch code, let's put some brightness around this so we can see it. I'm going to run it. So I see that I got the error, index was outside the bounds of the array, and I printed out my line. And then I did get this message in the finally clause. So that did run even though there was an error. And then it did return the 2 collections that it was able to create. Okay. Now, questions about that. The try-catch always really brings up a lot of questions. So what are you thinking about that?
The finally clause. Is the idea it only triggers if there's something that is like caught?
Ooh, let's try it. So what if we don't get an error? What if we make our array big enough like it used to be? Do we still get that finally message? Well, that's a good question. We might not want it. Oh, but yep, we still get it. So our finally clause runs either way, whether there was an error or not an error. We don't have to have that. So we could eliminate the finally clause, it's optional. We usually use it to close things or make sure that if there were any resources left over, we've released them.
Okay, but it's really just like a semantics. Like, okay.
We don't have to have it. We do have to have the try and the catch. We can't have one without the other. So we have to have each of those.
And then so does that, so that I understand, it runs all of that and then it runs the code. Like, that makes sense. Like it runs the try catch finally and then it runs the rest of it because it shows up first. Like it runs it 2 separate times or something like that.
Well, you better put it on the breakpoint and run it and see. Let's set it up. Let's go to our driver class and try it. Really good questions. So it's all in my database here. So I could set a breakpoint when I call that, and now it should let me step through everything. I'm going to run this. And when I step into my code to go generate my test data, we should see as it gets started, we have our compilation array get created. We should see it now in our locals window as soon as we create it. Still not seeing it. Keep going here and maybe I will. We'll add our first entry. Finally, there's one. Here it goes. It's going into our compilation class to add that entry. We add our second entry. Add it, add it, add it, add it. Our third entry. Now, watch it as it goes. It's still within your try. Now, we're done building our test data. So we're going to return back to our driver. Because we're going to return back to our driver, before we leave, our try block is still active, so we're going to execute our finally to finish it, and then return back to our caller. So our exception block was never run. Let's stop this. And now in our database, let's set our index real low, so we know we're going to get an error again. And try. So I'm here ready to generate my test data. I'm going to go into my generate data method, create my array. First compilation go in. There it is. The second compilation go in. Here it goes. And now I should crash because I can't fit this third one. So when I try to make that third one, here it goes. I see my exception start running. Now, it's weird how the debugger showed us that. You can think of it as, you know, it's just out of space. So here's our exception running. and it says our message was index was outside the bounds of the array, we can look at that exception object and see information that would be meaningful to different developers. But as we run through, we see our exception get processed, then our finally clause, and then we get done because we've had a runtime error. So now we go back and process each of our entries in our driver class. So these are such good ones for you to use the debugger and, you know, just kind of step through and try to get an understanding of what's going on, because we do have many layers here that are working with each other. I answer that one, I'm not sure. Sort of. Sometimes it's like difficult to answer.
And then if it does fail, anything after that failure in the try will just not get executed.
Will just not get executed, right? So it'll just kind of ignore the rest of it. Now in your Replit, you'll create a small application that does like a divide by zero and overloads an array so that you can try all of the different exceptions and catch them. Let's see, let's make sure everybody can get to that. I think this is your last one. Last Replit. You'll be so glad. Can you guys get to it? Is it letting you? Okay, we'll stop here for lab time so that you can work on this Replit and the previous one too, the class one, I know. Now next time, we'll be working on this TFS treasure hunt, and TFS is like GitHub. It's a source control facility. And so the rest of our semester, since we won't be working with Replit anymore, I won't be grading from Replit, so we'll be using TFS. So next time when we work with TFS, to be super important because you're going to see how to save your code so that it can be graded for the rest of the semester, kind of our last quarter and a bit more than our last quarter of the semester, because we'll be working with forms-based stuff, and Replit doesn't handle those GUI applications, so we'll do things a different way. So don't worry about starting that one until next week, until next time, so we can talk about it together. But I think that should do us. Any other questions? I know you're going to come up with some, so just yell if I'm up here not paying attention, and we'll get them all figured out. This lab time, work on your Replit, the one that is ongoing, and your new one. And I'll be here, but I think I'm going to stop our session if we're okay. Gotcha.